had a dog that was just too smart to be a dog? What about a dog that could fool an algorithm? I found this guy abandoned when he was about 4 months old, and he's been my co-pilot ever since. We've traveled together, we've shared a tent together, we've gone exploring together. My AI doorbell thinks he's a person. But he's not a person. My AI doorbell uses a type of artificial intelligence called deep learning to photograph and classify anything that moves in my doorway. Take this image as an example.
Object identified. Starting program.
The algorithm will zoom in as far as it can to get the pixelated version of the image, and then it will identify between a scale of 0 being the darkest pixel to 300 being the lightest pixel, the average of all of the light in that pixel. Once the algorithm has determined the border around the object, in this case the dark pixels, it'll go through its library of images and determine what the image is. Are you secretly a person? The algorithm is instructed to continue to learn as new information is presented, so that it can use that information to classify more information accurately. Well, it's certainly not more accurate to classify my dog as a person. So what's going on here? I'm lucky to have literally every photograph that my AI doorbell has taken since I installed it over a year ago. So I can use those along with my knowledge of artificial intelligence and deep learning to figure out how my dog managed to outsmart this algorithm. So convolutional neural networks are the fancy algorithms that classify images. You've actually been training them for years when you do those CAPTCHAs to prove that you're a human. The algorithm starts with a bunch of images and divides those into two sets. The smaller set is the training set, and the bigger set is the test set. The algorithm will look at an image inside the training set and analyze it pixel by pixel, and it'll mark it as either a 0 or a 1 for light or dark. And it begins to learn the names of the shapes that it identifies. Once it's done with training, it'll take what it learned about those shapes and apply it to the larger test set. When we get an error like the algorithm classifying my dog as a human, that error was most likely caused by the training data set. Now, images and pictures are by definition not linear, meaning that the algorithm can't use a simple line to determine what that object is. Instead, it will try to draw a curve. You know, dogs aren't a line, they're a bunch of curves, just like people. And in drawing stuff as a curve, it forces the algorithm maker to make a choice. Do I make a curve that exactly matches this training set, or do I let the algorithm make mistakes and misclassify stuff? Algorithms that have a curve that exactly match the training set run the risk of memorizing information that's not important to categorizing that image. For example, both of my dogs are black. Does this mean that all dogs are black? If the algorithm made its curve exactly to the training set, the answer would be yes. It would think that all dogs are black. Then if I get a white dog, the algorithm won't know what it is because it's the wrong color. You understand what I'm getting at? Now the alternatives is to not fit the curve exactly to the training set. This allows the algorithm to make mistakes. When there are data points outside of the parameters of that curve, it could potentially misclassify stuff, like maybe identifying a dog as a person. My dogs and I leave for a walk almost every day, so I have a lot of footage of that. Here we go. And here we are coming back. Obviously, I sometimes leave the house without my dogs, but they're not supposed to leave the house without me. So there really doesn't exist much in the data set, if anything, of the dogs being in the doorbell hallway without me. I also periodically carry objects of different sizes from my car to my house. Now, the algorithm's creator must have anticipated that people, sometimes carry stuff and instructed the algorithm to recognize that. Hence, the algorithm says, hey, humans, they sometimes shapeshift. I'll adjust. Now, this happened when I was doing some necessary home improvements a while back. I had contractors frequently entering and exiting my house. And they carried stuff, a lot of stuff. They wore headphones, they ran power tools, power tools, had cords and other stuff attached to it. And I imagine this is what tricked my doorbell algorithm into thinking that humans can have ears that are shaped abnormally, and the extension cords probably look like tails or, dog leashes. So the algorithm went over that new data, divided into training set and test set, and determined that dogs can be people. It learned that humans can have dark, oversized ears, tail-like objects when we're carrying stuff. And that would make our body, an abnormal shape. We have a word for this type of misinformation that can affect whether or not an algorithm is being accurate. It's called noise. Humans have critical thinking skills. We can look at a lot of noisy data and characterize what is important and what is not important. Algorithms can't do that. Algorithms are just a bunch of functions, let's call it function soup. They don't know what is supposed to be in there and what's not. Humans, we can say, look, dogs aren't people. People sit on furniture and lay in beds. Dogs sit on the floor. People contribute to the mortgage. Algorithms are math, and they're not sentient beings. They don't have critical thinking skills. So this algorithm now cannot tell the difference between noise and good data. So here we are. The algorithm thinks that my dog is a person, which is something that my dog has known all along. Now, this might seem like just a funny little quirk, but it's important to recognize because some far more sinister implications for society could result if algorithms that are much more important than some middle-class white lady's doorbell algorithm start misclassifying stuff. And here's what I mean. More than 90% of the data that my doorbell camera has to train is just images of me with the dogs. So let's imagine for a minute that this is not just the doorbell camera on the house of a techie middle-class white woman in America. What if it's the security camera on a bank in a mostly white suburb? And what if instead of learning data about 2 black dogs and then not knowing what a white dog is, what if it's a test set of white humans and then 1 non-white human? This is not the video where I will go into racist algorithms. I definitely should make that video, but this is not that video. Nope, this video is about my dog and my doorbell camera. Oh my god, look at this dog! Look how cute he is! He's so cute! Look, he's going after a rock! Look at him, he's a little geologist. He likes rocks. Look at him, he's so cute. I'm gonna subscribe to this channel. The creator's a little weird, but I'll support her so she can buy food for this adorable dog. Look at him. Look at him. This channel should get 1,000 subscribers just because of this adorable dog.